All right, as promised, I'm going to run through the solutions to the Chapter 4 practice test. Number 1, graph. We must find the vertex first. The vertex is located at negative b over 2a, the x-coordinate of the vertex. B is negative 6, so there's that double negative situation. So we have 6 over 2 times a is 1. So 6 over 2 would be 3. So the x-coordinate is 3. Now I'm going to build myself a table. 3 is the center point, so it goes in the center of the table. When I can use 0, I always like to use 0. 0 is easy to plug in. 0 squared minus 6 times 0 would all be 0, so the answer is 4. Because of symmetry, I don't really have to figure out what the answer is for 6. 6 is 3 spaces above 3, and 0 is 3 spaces below 3, so its answer is also 4. If you don't believe me, just plug it in. 6 squared minus 6 times 6 plus 4 would also be 4. So my only real work is to plug in 3. So I'm going to put 3 into the equation. I get 3 squared minus 6 times 3 plus 4. You can use a calculator, figure it out however you want to. It'd be 9 minus 18 is negative 9. Negative 9 plus 4 is negative 5. So all of that answer is negative 5. So once I have that, I can now graph my parabola. So you plot the 3 points and you get a parabola. And so I'm going to skip on because plotting the 3 points is pretty self-explanatory. And I don't want this video to be a million hours long. Number 2, I don't have to calculate the vertex. The vertex is sitting there for free because it is the vertex form of the parabola. The h always sits right here, and the k always sits right here. So the h is 3, and k is 4. So 3, 4 is the vertex. And again, I would go over 3, up 4, plot the point. And I'm not going to just to save time. I need to pick numbers that would work well. This time, if I use 0, I'll go off the graph. So I'm going to pick 1, and that's 2 spaces below, and I'm going to go 2 spaces above to 5. Those should have the same answer. So I'm going to take and plug in 5. So 5 goes in for x. 5 minus 3 is 2. 2 squared is 4. 4 and 4 make 8. So this is 8, and this is 8 as well. And then again, you graph the 3 points, and you get the parabola. All right, the next one is find the following on this parabola here. And the h and the k, again, are sitting right here. The h and the k, that's the vertex. What's missing that you don't see is it's minus a negative 2. So it's x minus a negative 2. So h is really negative 2, and k is just sitting there negative 10. So it's negative 10, comma, or negative 2, sorry, comma, negative 10. The y-intercept is always where x is 0. So you put 0 in for x, and you calculate the answer. So that would be 0 plus 2 squared minus 10. So I'm putting 0 now in for x. So that would be 4 minus 10 is negative 6. So 0, negative 6 is the where the y-intercept is. Axis of symmetry is just the x-coordinate of the vertex. The minimum is the y-coordinate of the vertex. The domain for all parabolas is all real numbers. And the range is everything above the minimum, because this parabola is going up. So it's everything above and equal to negative 10. So greater than or equal to negative 10. So there's the answer to that one. Moving on. So again, if you need to fast forward, pause, rewind, whatever, it's a video. You can do that over and over again. If you want to watch the explanation 10 times in a row, do that. This is just a quick and fast way through the solutions so that they come alive versus just staring at them on the paper. Okay, vertex form. Well, we need the vertex. The vertex is at negative b over 2a. I'd also like to point out that a is 1. So I know that a is 1. I got that because I need that. I need h and k. So this will tell me what h is. So it's negative 2 over 2 times 1, negative 2 over 2, which would be negative 1, and there's my h. So I have my h, and I have my a. Now I need k. Well, h and k are an ordered pair. So we put the negative 1 back into the problem. So it's y is equal to negative 1 squared. If you don't put those parentheses around there, the calculator will square it wrong for you if you're using a calculator. 2 times negative 1 minus 4. So negative 1 squared is 1. Minus 2 minus 4 would be negative 5. So negative 5 is the y-coordinate of the vertex, or k. So I have a, h, and k. Now I write it out. Y equals 1, x minus h, but since h is negative, it's plus 1 squared minus 5. So there it is. Okay, now we got a whole page of factoring. So 2 sets of parentheses. Now I scanned this into the computer and look how, or into the copy machine. Look what it did there. Instead of it being, it like made it a peanut shape instead of being or a circle. So it looks a little bit better on your paper. It morphed it a little bit. Okay, so 2 sets of parentheses. Put an x here and here. We think about what multiplies to make 75. That would be 5 times 15. And that's good because they differ to make 10. The 15 needs to be positive and the 5 needs to be negative. So you always FOIL it back out to check your work. You really don't need to check the x times the x or the negative 5 times the 15 because I chose those to be x squared and 75. But you do need to check this. Does that make negative 5x? Yep. Does this make positive 15x? Negative 15 plus the 5 will make the 10. So that is the correct solution. The correct solution is the blue. Let me get that off of there, and there we go. Okay, I have a 2 in the front, so I have to make sure I account for that. So it's going to be 2x, and then x. 24. There's lots of ways to make 24. If I try 12 and 2, so 12 and 2, no, that wouldn't work. How about 8 and 3? Oh, if I put the 8 opposite the 2, 8 opposite the 2 would make 16. And then put the 3 there. Okay, that'd be 3x and 16x would make 19. Both of those are negative. Number 7, the difference of two perfect squares always factors the same. Factors into x, and the square root of 16. So it's plus 4 and minus 4. Okay, I'm going to do the GCF first, then factor it a second time on this page here, or these set of problems here. I'm going to take out 5 because it is the common factor. So it's like dividing it out or factoring out using the distributive property backwards, however you want to think about it. So it's x squared minus x minus 2. And then I'm going to make 2 sets of parentheses here. And take a sip of water. All right. So this is kind of like number 1 now, or not number 1, but number 5. But it has this 5 in the front, but it is x squared. So x squared always goes to x and x. 2 has to be 2 and 1. There has to be negative 1 in the middle, so negative 2 plus 1. Okay, the next one requires that I just take out a negative, so negative 1 goes in the front. So it's x squared minus 13x plus 12. That changes all of the signs, flippy signs. Negative 1 drops down. And again, I have the x squared business, so it's x and x. 4 and 3. Well, 4 and 3 would make 12 by multiplying, but 4 and 3 doesn't make 13, but 12 and 1 does. So minus 1 and minus 12. Okay, number 10 factors twice, taking out 5 because 5 is the common factor. And I would have 25 left over. So it's x plus 5 and x minus 5. Difference of two perfect squares. Just like the one above it. Just like the one above it, but it's has an extra 5 there that I had to factor out first. Okay, the next one is the zero product proper T. So if A or B is 0, then this statement would be true. The first thing could be 0 or the second thing could be 0. So basically I want to factor it into something times something equals 0. And that's what happens in every single one of these. So I factor again. 2 sets of parentheses, put an x in each, 9 in one, negative and positive. That should make negative 8 in the middle. And now I do zero product proper t. I go x minus 9 equals 0, x plus 1 equals 0, and I get x equals 9 and x equals negative 1. So I got to solve for x on each one of those. So I added the 9 over, I subtracted the 1 over to solve. Okay, number 12, factor again. 2x, just like up above, it has to be 2x and x. 5, there's only one way to factor 5. I want to put the 5 opposite the 2, so I'd make 10x, and the 1 with the x to make 1x. So negative 10x and negative 1x makes negative 11 in the middle, equals 0. And I have 2x minus 1 equals 0. Set each factor equal to 0. Add 1. 2x equals 1. Divide by 2. I get a half, so a fraction. Add 5 over, and we get x equals 5. So I got 5 and 1/2 are the two solutions. Okay, the next one is taking out the common factor. I'll draw a line right there. 3 is a common factor and also x's, so I divide those out or pull them to the front. So I have what left over when I take out 3x? Well, I have an x and I have a minus 4 equals 0. Do 0 product proper t, 3x equals 0, x minus 4 equals 0. Now I divide by 3, I get x is equal to 0 and x equals 4. Let's see, how are we doing for time here? 12 minutes, okay, we're working on it. All right, next page. Okay, solving by completing the square. Solving by completing the square, you have to worry about the middle here. So we're going to take half the middle square, but I can't do that until I move the 3 over because I have to have a blank space. To move the 3 over, it's minus 3. I'm going to add the 3 over. Then I do half the middle term squared. Half of the middle term is 3. 3 squared, 3 times 3 is 9, so I add 9. Not just to one side of the equation, but I have to keep it balanced, so I got to add 3 to each side of the equation. And I now factor. This factors into x plus 3 times x plus 3. So I get x plus 3 times x plus 3, which would be x plus 3 quantity squared. The other side of the equation is simply just 12, isn't it? Once I get this situation going, I take the square root of each side of the equation to do the opposite. So I get x plus 3 equals plus or minus the square root of 12. I bring the 3 over, I subtract it over, so x is equal to negative 3 plus or minus the square root of 12. And that's a pretty good answer, but I realized that 12 is really the square root of 4 and the square root of 3. That's the same thing as the square root of 12. And I did that because I just took out the largest perfect square. The largest perfect square was 4. And I can now take the square root of 4 to get 2. So this is how I got my final answer of negative 3 plus or minus the square root of 4, which is 2, radical 3. All right. Number 5. I already prepared it for you. There's a blank spot, but the payoff is you have to do half the middle term squared. Well, half of 3 is 3 halves. And when you square that, you get 3 times 3 and 2 times 2. So you add in 9 fourths. Okay, so it's half of 3 is 3 halves. 3 halves times 3 halves would be 9 fourths. Okay, now it factors into x and x. And I encourage you to leave it with a fraction because then you can see how it factors. It factors into 3 halves times 3 halves because 3 times 3 is 9, 2 times 2 is 4. Okay, now I need to add 2 and 9 fourths together. If I add 2 and 9 fourths, it's basically 4 and a fourth, or said differently, that's 4 and 1/4, or 17/4. And you really need it to be an improper fraction. So to do that, you do 4 times 4 plus 1 is 17. Okay, rewrite x 3/2, and then that squared is equal to 17/4. I can do the square root of each side now. Taking the square root of each side would be x plus 3/2 equals plus or minus the square root of 17. And 4 square root is 2. Subtract over the 3/2, and you get x is negative 3/2 plus or minus the square root of 17 over 2. All right, 17 doesn't simplify. It's square root of 17 is just square root of 17. It's a prime number, all that business. All right, moving right along. Quadratic formula. You identify a, b, and c, and you go from there. So a is equal to 1, b is 3, and c is 7. So it's 1, 3, and 7. A, B, C. Don't take the x's with it, just the a, b, and c. Now we go to the formula. The formula is over here. I put it on the test for you, negative b. So it'll be x is equal to negative 3 plus or minus the square root over 2a. Well, 2 times a is just 2. Now we do b squared minus 4ac. And I did switch the colors for that. So it's b squared minus 4a is 1, c is 7. Okay, that goes into the calculator, the green part, or you can calculate it out yourself. It's not too hard to do. It'd be 9 minus 28, which would be negative 19 over 2. Now, when you get a negative square root, you pull out the negative, and that turns into I. So the final answer is negative 3 plus or minus I radical 19 over 2. 19 is a prime number, so we just stop right there. All right. Oh, MG. I just realized that I made a mistake on the answer key. I did the answer key really super fast. So I did 2B. So the answer is actually right on the video. Okay. Um, yeah, it's over 2A, 2 times, it should be 2. So it'd be negative 3 plus or minus I squared 19 over 2. Yep, I said it was over 6 on the actual answer key. That's a whoopsie. I'll make a note of that on Google Classroom, and hopefully you guys won't freak out on that. It's supposed to be 2. So I caught my mistake. Next one. We have to move over the 1, so it's 16x squared minus 4x minus 1 equals 0. So to do the quadratic formula, you must be set equal to 0. Okay, identify a, b, and c. A is equal to 16, b is equal to negative 4, and c is equal to negative 1. Okay, so it's negative negative b, so it'd be 4 plus or minus the square root b squared, so well over 2a, well 2 times 16 is 32. So I'm going to do b squared, so negative 4 is b squared minus 4a is 16, and c is negative 1. So the green part's the discriminant. We go ahead and do that, and we get 4 plus or minus the square root of 80. So the green part goes to 80 over 32. Okay, then we notice that 80 can be split up into, I've always split them up with red, 16 and 5. So 16 times 5 makes 80. It's the largest perfect square. That goes into 80. So we get x equals 4 plus or minus 4 square root of 5 over 32. Now we notice that each one of these, I'm going to highlight it in yellow. Let's get the yellow highlighter to come up here. There it is. There, there, there. So all those are even, but they're also multiples of 4. So you can divide all of those yellow parts by 4 to get a final answer of x equals 1 plus or minus the square root of 5 over 8. And that would be the best answer. All right, number 18. Woo! Hang in there, we're almost finished. Number 18 is the discriminant question. It's kind of fuzzy, so you're going to have to look off your paper, but it's just um, kind of hard to see for me because I scanned it and then ran it into this program here. But what it says is we have the number of people, I believe it is. Yeah, so t squared minus 10t plus 40 represents the number of people in the elevator. Well, will that ever reach less than 15? So I'm going to solve this a little bit differently than what I did on the answer key. I'm going to say, okay, less than 15 would be 14. So is it ever 14 people? So you can't have quarters or halves of people. So I'm going to say, does it equal 14? So on the answer key, I said, does it equal 15? Well, 15 would be equal to what it says, and then less than 15 would be 14. Okay, so we are going to um, do the discriminant test on this to see if the discriminant test is positive or negative or 0. I'm going to subtract over 14, and I get t squared minus 10t plus 26 is equal to 0. So now I'm going to do the discriminant test. So d for discriminant equals b squared, which would be negative 10 squared minus 4a is 1, and c is 26. So when I figure this out, it would be 100 minus 4 times 26 would be 104, right? Should be 104. Yes, 104. When I subtract that, I get negative 4. So the discriminant is negative. Since the discriminant is negative, that means this situation is impossible. It cannot happen. So that's kind of the story with that one. So when the discriminant's negative, it can't be a possible situation. So there's never less than 15 people on the elevator. All right, let's do these four right here. Square root, square root, square root. 3 square roots. Negative 1 comes out because you can't take the square root of a negative. The largest perfect square that lives inside of 75 is 25, and then what's left over is 3. So negative 1 times 5 times 3 is negative 75. So I would simplify this to 5. The square root of negative 1 is I, and then radical 3. Okay, adding. Adding is easy. You just add. 11. Okay, 2 minus 3. 2 minus 3 is negative 1. So it's 11 minus 1i. Subtraction. Subtraction, you must distribute. So it's going to be negative 3 plus 8i. Just distribute the negative in front. So it's negative 4 plus 5i. Then we collect our like terms. Negative 3, you borrow $3, you borrow $4, so you owe 7. And then we put the 5 and the 8 together. 5 and 8 makes 13, so it's 13i. Okay, multiply. Basically, we're going to use FOIL, and we're going to use the fact that I squared is equal to negative 1 at the end. So foiling this out, 3 times 7 is 21. 3 times the 9 would be negative 27i. 2i times 7 is 14i. And 2i times the 9i would be negative 18i squared. These are like terms. They go together. I'm going to drop the 21 down. So I owe $27. I pay back 14. That means I still owe 13. So it's 13i. Now remember, I squared is negative 1. So it's negative 1 times the negative 18. So it'd be plus 18. So it flips the sign there, makes it positive 18. These are like terms. They go together. You have $18 in your pocket and $21 in your couch. So you now have a grand total of 39 together. So it's 39 minus 13i. All right, so there's that page. And now, the last page. Yay, the last page. Okay, so systems algebraically. So we know that since this is equal to this, these are equal to each other. So I write down negative x squared plus 2x plus 10 is equal to x plus 4. We get everything on the same side set equal to 0. So we're going to subtract the x and subtract the 4. Line up the like terms. So we get negative x squared plus x plus 6 is equal to 0. I don't like the negative in the front, so I flip-flop the signs by multiplying everything by negative 1. So I get x squared minus x plus, whoops, not plus, minus 6 equals 0. This is now set up for factoring. You could do the quadratic formula on it, but factoring is way easier. And by zero product property, you set each one of those equal to 0, and you get x equals 3 and x equals negative 2. So those are my two solutions. But I'm not done until I put the solutions back in and find y, because you want to have the whole answer. So my solution points where the two things intersect is at 3 comma some y point and negative 2 comma some y point. So I'm going to put the 3 and the 2 back into the easy equation and calculate y. So 3 and 4 make 7, so 3, 7 is a point. Put negative 2 back in, negative 2 and 4 make 2. So those are my two solutions. All right, the last problem. Yay, the last problem. And it only took 20, well, it'd be close to half an hour going through this. Of course, it doesn't take me a half an hour to do this since I don't have to like talk and explain through everything. Plus, I've stopped a couple of times and gotten a drink of water, which I'm going to do again. My cup is empty. Here we go. The vertex is h and k. So there's an h, there's a k. My x and y point is 7, 7. So I know y, x, h, and k. I have to solve for a, and then I can write the equation of the parabola. So y is 7. A is unknown. X is 7. H is 5. And K is 3. I made a video about just this topic. Make sure you do this first. That has to be done first, otherwise it'll mess it up and be multiplied times A. So 7 is equal to 7 minus 5 is 2. 2 squared is 4. So it'd be 4A plus 3. Now it solves like a regular algebra problem. Subtract the 3 over. So you get 4 is equal to 4A. Divide, A equals 1. So now that I know A, H, and K, I can write the equation in vertex form. 1x minus 5, there's my H squared, plus K, which is 3. And this parabola equation holds those points and etc. backwards and forth.